I walk through the valley of the shadow of death, I take a look at my life and realize there's nothing left. Cause I've been blasting and laughing so long that even my mama thinks that my mind is gone. But I ain't never crossed a man that didn't deserve it. Me be treated like
Newton's first law is the law of inertia. This first law states that an object at rest tends to remain at rest, and an object in motion tends to remain in motion at constant speed. Some say that the law is an object maintains a constant velocity unless acted upon by another force. For this demonstration, we will be showing how a ball being kicked, then being stopped, is expressing Newton's first law. The ball not moving and being still is an example of an object at rest will remain at rest. When being kicked, thin is the first example of the unbalanced force acting upon the non-moving ball. The ball in the air is an example of an object in motion will continue with constant speed and direction until it is acted upon by an unbalanced force. Since Preston is the one who stops the ball, he is the second example of the unbalanced force in this demonstration. Newton's second law states that when a net force acts on an object, the object will accelerate, and that the acceleration is directly proportional to the net force and inversely proportional to the mass. For this demonstration, we will be dropping two objects off the Newell Hall steps. The first object is a tennis ball, and the second object is a basketball. You may assume that the heavier or even the bigger object will hit the ground first, but according to Newton's second law, the heavier an object is, the acceleration will decrease because it has more mass. This is because the acceleration is directly proportional to the net force and inversely proportional to the mass. Our example is not completely accurate due to the way the ball was dropped, but if both balls were dropped completely at the same time, they would both hit the ground at the same time. Here is another example. Since force is directly proportional to acceleration, the less amount of force means the less amount of acceleration, and the more amount of force means the more amount of acceleration. But the size of the mass does matter if you are putting the same amount of force for both objects. Now remember, mass and acceleration are inversely proportional, which basically means they're opposite. Since the mass of the top picture is smaller than the car, the acceleration is greater. But since the mass of the car is bigger than the top picture, the acceleration is slower. This is all due to Newton's second law. Newton's third law, which is known as the law of action and reaction, states that whenever one object exerts a force on a second object, the second object exerts an equal and opposite force on the first. For this first demonstration, we will be showing some of Titus's plays. Titus is the first action happening. He is the object exerting a force on the second object. For this example, the second object is the Fogeye tool pair. The second demonstration is a ball being thrown at Thane. The ball moving towards Thane is the action. Thane is the reaction. When the ball exerts its force on Thane, Thane exerts an equal and opposite force. The third and final example of this video take-home lab project for Mr. Nakamatsu's Period 7 class, which starts at 11:55 a.m., is simple walking. When walking, you are the force and action on top of the earth. The earth is the reaction on you. This is all according to Newton's third law. The same rule applies for cars driving on the road.
like